Example 162 tech. Find the least squares prediction line for the following pre-owned Corvette data. So they basically have the age of the car, right, how old it is, and then they have the price of the car, right? And the price of the car here is expressed in just dollars. When we look at the Minitab output here for this problem, the prices have been changed to be expressed in tens of thousands of dollars. That means if you want to convert them back into dollars, you got to multiply them by 10,000, or in other words, move the decimal place over 4 times. All right, so here's that Minitab output. So again, if you move the decimal place over 4 times, this y-intercept becomes $43,860, right? And the slope becomes 2,911. Okay, so let's go ahead and form the model, and then we'll answer the question that exists in example 163. All right, so in example 163, they're asking what would the average price be for a Corvette that was 3 years old? Well, since we have our model, and our model is that y hat is equal to negative 0.2911 times x plus the y-intercept of 4.386. Remember, where we're getting these from is just the coefficient column here. And remember that the one that has the name of the measurements that go in for the x variable, that is your slope estimator. The constant is always your y-intercept. So remember, the constant is the thing that does not have the x attached to it in the equation. The other item will be the thing that x is attached to in the equation. So the constant, remember, is the y-intercept, and the other variable will represent the slope estimator. Okay, now what you're going to do is plug in the x value that they're talking about. In this problem, they're talking about 3 years old, so we're just going to say, if the Corvette was 3 years old, we'll plug in 3, so 0.2911 times 3 plus 4.386. Let's see what that gives us in the calculator. So I have minus 0.2911 times 3 plus 4.386. And we get 3.5127. So 3.5127. So remember, if I want to convert that back into dollars, I have to multiply by 10,000, or in other words, move the decimal place over 4 places. So this, if it goes over 4 places, ends up giving you $35,127. Okay, and remember what that represents. That's the price that the average 3-year-old Corvette would sell for, based on the time when this data was collected, of course. So one thing you want to keep in mind, by the way, before we leave this equation is that whenever this slope is negative, whenever this estimator actually has a negative value, that's an indication that the variables move in opposite directions, right? That means they're negatively linearly related. That means that there's a negative relationship between the two variables, x and y. And if you think about this equation, it makes sense that as the age here on the x-axis increases, the price of the car will generally drop, right? Now this is going to happen for a certain amount of time. Remember, cars eventually hit the classic stage and they start to go up in price. But it makes sense that when a car is close to 0 years old, it'll be its most expensive. And then as it gets older, it'll tend to drop in price, right? People prefer new cars to older cars. They prefer the new model. So there's going to be a general downward trend in the data. So we expect to see something like this, where we have a bunch of values kind of all scattered around, some generally straight line going that way, right? Okay, so that's basically the idea. And the slope is negative because that's kind of going downhill as you move left to right. And that's sort of the idea. So it makes sense that the slope is negative, and you do want to just kind of check that mentally when you look at an equation like this. Make sure that it makes sense, intuitive sense to you. And yes, it makes sense that, at least for the short run, the older the car gets, the lower the price usually is. Now, of course, there's a point where this curve would actually probably start to turn and go back up, right? And that would be when the car hits that classic level, right? When it's so old that now it's a classic. And that's actually a good example why we want to make sure that when we plug in numbers for this x value, we stick within the range of x values that they use to create the model. So if we look back up at the data that they used for this model, you'll see they used years ranging from, it looks like a minimum of 1, and then they went all the way up to, say, 6, right? So we wouldn't want to work too far outside of this range. We'd probably want to stay within values from 1 to 6. So 3 is okay because it's right between those numbers, but you wouldn't want to put something like 20 in there, right? Because of course, at that point, it might be that the car starts to go back up in value, and the model would no longer be predictive at that point. So you want to be careful when you use the model that you only make predictions with it within the range of x values that you use to create the model. That's generally a good piece of advice.